Hello everyone. Today we are going to talk in this lecture about quantum mechanics in your advanced engineering physics. This is Dr. S. Deepthi, Assistant Professor in Physics, Department of H&S, MLR Institute of Technology. So, as a part of this, what we are going to learn today? We are going to learn about introduction of quantum mechanics, de Broglie hypothesis, properties of matter waves. Now, what is quantum mechanics? This is a bit lengthier and also a very good concept. Okay, let us dwell this concept. Quantum mechanics gives the most accurate and complete description of the world. This theory came into existence with the failure of experimental results of classical mechanics at microscopic level. Okay, classical mechanics means the mechanics that deals with the objects that we can see, whereas quantum mechanics means the quantum mechanics deals with the objects that we cannot be visible with our naked eye. Okay, so classical mechanics explains the dynamics of bodies at normal distances and properties of light based on electrodynamics. Hence, a new theory was developed to explain the properties of microscopic system with accuracy. Quantum theory is the fundamental theory that explains the properties of matter at atomic and subatomic levels, the radiation and interaction of radiation with matter. So, what we are going to learn in this video lecture or in this quantum mechanics, that is, this theory is a fundamental theory that explains the properties of matter at atomic, subatomic levels and radiation and interaction of radiation with matter. Okay, this theory was developed by Max Planck, Albert Einstein, de Broglie, Werner Heisenberg and Schrödinger. The description of microscopic systems is done through wave mechanics in terms of continuous wave function. So, you need to remember what is wave mechanics. Just keep that in mind about these two words, wave mechanics and wave function. We'll discuss in the next slides. So, what is there here? What is the diagrams depict? See the diagrams, atomic and subatomic levels we have already just noted down now. What are atomic and subatomic levels? An atom consists of what? An atom consists of? An atom consists of a nucleus, and around the nucleus there are several orbitals where the electrons are arranged in a particular orbitals, and this is according to the Aufbau principle. Okay, so here also, here the beautiful diagrams depicts that one, an atom at the center and with the nucleus, and all the electrons are revolving around the nucleus. See here, there are different electrons are revolving here in a particular orbitals like this. Okay, this diagram depicts like this. Okay, and also here also another diagram, the electrons are moving around the nucleus. Here we can see that the electrons are moving around like this with a different orbitals surrounding the surrounding the nucleus, right? And also here we can observe the structure of an atom, the structure of a molecule, sorry. Okay, so the structure of molecule, and these are all interrelated, and quantum mechanics deals about atomic and subatomic at molecular and microscopic level. Okay, so these are all the dealings, that means how the energy transfers within atomic and subatomic levels and the interaction of energy with matter and so on. Okay, we shall see in the next slides. Now, wave particle nature, wave and particle. Okay, so what is a wave? What is a particle? Let us have the specifications. Wave particle duality is a concept in quantum mechanics that every particle can be described by either as a particle or a wave. Okay, so this wave particle duality, wave and particle duality, is a concept in quantum mechanics that every particle can be described either as a particle or wave. Remember that. What are the specifications of particle? Particles means particle has a mass, velocity, momentum and energy, etc. What is a wave? A wave is a disturbance created in a medium, and it is specified by its frequency, wavelength, phase or wave velocity, amplitude and intensity. So, can we find anything in common between mass and for frequency or velocity and wavelength? There are no direct relationship till de Broglie introduced something. Okay, so we have different parameters for particles and waves, but in quantum mechanics they have come into both are combined together to have a dual nature of matter. Okay, so let us consider wave particle duality insists that matter and energy possess both wave-like and nature and particle-like properties. Wave-like nature means it travels in the form of waves, and particle-like means it has mass, it has velocity, and it has momentum and energy and so on. Right? So this duality is the fundamental principle of quantum mechanics and applies to both light and matter. It applies both to the light and matter. Light means the energy that we can see or the energy that that is generated in the form of waves. Okay. And also what is a matter? Let us see about what is a matter in the next slides. So see here, the wave is represented like this with a thrusts and troughs and all so on. This is the representation of a wave. And what is a particle? A particle is represented with a circular notation. And wave particle duality means within the particles there will be waves, and within the waves there will be particles. We shall discuss in the next slide. So now de Broglie hypothesis. What is the matter? In the earlier slide we have already seen about what is a we have already come across the word matter. Now what is a matter? Matter is anything that has mass and takes up space. That has mass and occupies some space. This is that you students are learning from the childhood onwards. Right? Matter is anything that has mass and takes up space. And matter waves have wave-like properties that all moving matter exhibits, a concept known as wave particle duality. So the concept of wave particle duality comes into existence where the wave-like properties will be there for matter waves where it has a particle in nature. Okay, so according to de Broglie hypothesis, a moving particle is associated with a wave. Remember this, a moving particle is always associated with a wave, which is known as de Broglie wave or matter wave. So we have came into the we got the matter wave definition. What is the definition of a matter wave or de Broglie wave? A moving particle is associated with a wave which is known as de Broglie wave or matter wave. So lambda is equals to h by mv. This is the relationship given by the de Broglie hypothesis, where lambda is the wavelength of a wave, h is the Planck's constant, m is the mass of an electron, and v is its velocity. mv is equals to mass into velocity is equals to momentum. Okay, so let us give this explanation, or let us derive this one derivation. Okay, so we know that from Einstein's mass energy relation, E is equals to mc square, right? This is Einstein's mass energy relation. If a matter moves or if a particle moves with some energy, then it do possesses some amount of frequency. E is equals to h nu. If the matter is moving with some energy, then the matter is which is equals to the energy is equals to directly proportional to the frequency, or E is equals to h nu. Let us consider this as 1, this as 2. Now equating both the energies. So mc square is equals to h nu, or h nu can be written as hc by lambda, where this is the relationship. Nu is equals to c by lambda. We know this relationship, the relationship between frequency and wavelength, that is equals to nu is equals to frequency is equals to c by lambda. So mc square is equals to hc by lambda. That implies lambda is equals to hc by mc square, that is equals to h by mc. Okay, where here h is the Planck's constant, m is the mass of a particle, and c is the velocity of light. For a material particle, lambda is equals to h by mv. Got the equation? Lambda is equals to h by mv, right? And where mv is the momentum, so it can be written as p. So wavelength is equals to lambda is equals to h by p. This is our required equation. Okay, the relationship between mass of a particle and its velocity to the wavelength of a wave. Okay, this is the famous relationship where this is the basic relationship that in quantum mechanics we are dealing with the relationship at most. Okay, next, coming to de Broglie wavelength associated with energy. If E is the kinetic energy of a particle, then the de Broglie wavelength is lambda is equals to h by p, that is equals to h by root over 2me. Okay, let us consider the kinetic energy. Kinetic energy means the energy possessed by the body by the virtue of its motion. It is known as kinetic energy, usually represented with Ke, but here we can represent with E. E is equals to half mv square. Okay, so 2E equal to mv square, or multiply with m on both sides. 2me is equals to m square v square. Okay, so mv equal to, that implies mv equal to root over 2me. So lambda is equals to, we know that de Broglie hypothesis, lambda is equals to h by mv, that is equals to, we can write as replace mv with root over 2me. Lambda is equals to h by root over 2me. If the kinetic energy is given, then the wavelength can be calculated by using the formula lambda is equals to h by root over 2me. Next, coming to, if an electron accelerates with velocity v through a potential difference v volts, then the work done on the electron EV, which is equals to the kinetic energy of the electron. Okay, the work done is equals to change in kinetic energy, that we what we have learned earlier, right? So here EV is equals to half mv square. Okay, so 2EV equal to mv square. So you know, note down the difference between this v and this v. This is the velocity of a particle and this is the applied potential difference, right? So multiply with m on both sides. 2mev is equals to m square v square, or mv equal to root over 2mev. Okay, this is the relationship. So lambda is equals to, we know that from de Broglie hypothesis, lambda is equals to h by mv, that is equals to h by root over 2mev. Got it? So by substituting the value of for mass of an electron, is equals to 9.1 into 10 to the power of minus 31 kg, and h is equals to Planck's constant 6.626 into 10 to the power of minus 34 joule second, and E is equals to charge of electron 1.6 into 10 to the power of minus 19 coulombs. These are the constants. By substituting this constant in this formula, then this leads to lambda is equals to 1.227 by root v in nanometers. This directly comes in nanometers. Okay, so this is de Broglie hypothesis. Next, coming to the properties of matter waves. Till now we have learnt about what is the relationship between wavelength and mass of a particle and its velocity. Wavelength of a wave, mass of an electron and its velocity, right? Now we are going to see what are the matter waves and its properties. What is a matter wave? A matter wave, a wave associated with a moving particle, right? So now let us consider about the properties. Matter waves have special characteristics when compared to the electromagnetic waves. The characteristics are: matter waves are not electromagnetic waves. So matter waves are not mutually perpendicular to one another. Matter waves are not electromagnetic waves. Smaller the mass of a particle, greater is the wavelength in it. Smaller the mass of a particle, lambda is equals to h by mv. We can know about from this relation. Smaller is the mass of the particle, the greater is the wavelength, and vice versa. Smaller is the velocity of a particle, the greater is the wavelength associated with it. When the velocity of a particle v is equals to 0, then the wavelength is equals to infinity. When the velocity of a particle is 0, the wavelength will be infinity. Proves that the matter waves are generated only by the moving particles. Okay. So, the matter waves, remember that matter waves are generated only by the moving particles. If v is equals to infinity, if v itself is infinity, then the wavelength lambda is equals to 0. So, the wave becomes indeterminate. That means no material particle moves with infinite velocity. Okay. So, no material particle moves with infinite velocity. Now, the velocity of matter waves depends upon the velocity of the material particle. That is not constant. While the velocity of electromagnetic waves is constant, which is equals to the velocity of light. Okay. So, here the velocity of matter waves depends upon the velocity of material particle. That is not constant. Okay. Velocity of a material particle is not a constant, whereas the velocity of electromagnetic wave is equals to the velocity of light. So, the matter waves are produced with the moving particles and the particles, whether the particles are charged or uncharged. Okay. So, matter waves can be produced whether the particle is charged particle or uncharged particle. If every particle, matter wave is produced with every particle where it is moving. Okay. Now, extending the properties. The velocity of matter waves is greater than the velocity of light. Let us consider this one. E is equals to h nu and E is equals to mc square. This is the formula that we have used in the earlier. Okay. H nu is equals to mc square, nu is equals to mc square by h. Okay. So, now the wavelength of matter waves is equals to lambda is equals to h by mv. Okay. The matter wave velocity is equals to u is equals to nu lambda. So, u is equals to nu lambda, the matter wave velocity. So, this is given by the, this is the equation for matter wave velocity. So, let us substitute nu is equals to mc square by h into lambda is equals to h by mv. So, this is equals to u is equals to c square by v. Okay. As the velocity of the particle does not exceed the velocity of light, hence the velocity of matter waves is greater than the velocity of light. Okay. So, see here, velocity of the particle does not exceed the velocity of light. So, hence the velocity of matter waves is greater than the velocity of light. This we can say from this equation. So, the matter wave velocity u is equals to c square by v. So, we can equate any of the things, right? U is equals to c square or u is equals to 1 by v. But can u is equals to c square we can equate, or we can compare between c square and the velocity of a material particle. Since the velocity of a material particle is not equal to the velocity of a light, so what is the remaining thing? The remaining thing is u, which is the velocity of matter wave, which is greater than the velocity of light. Okay. The wave and particle aspects of moving objects can never appear together in the same experiment. Okay. This we need to remember here. The wave and particle aspects of moving objects can never appear together in the same experiment. Wave have particle-like properties and particle have wave-like properties. Both are inseparable. Okay. So, we cannot separate the wave-like properties of a wave, particle-like properties of wave and wave-like properties of a particle. Okay. The wave nature of matter introduces an uncertainty in the location of the position of the particle because the position of the wave cannot be identified. Okay. So, this is about Heisenberg's uncertainty principle that we will learn in the next lecture. So, in this lecture, what we have learned? We have learned about de Broglie hypothesis and properties of matter waves. In the next lecture, you are going to learn Heisenberg's uncertainty principle and wave function and its physical significance. Thank you.